Hello, everyone. We believe that watching soccer is fun, and here is an example why.
Good run by Messi. Oh, what a tremendous goal!
Right? So what we want to do is that we want to take the experience of going to a stadium and watching a soccer game live and bring it in your living room. And we propose to do that with augmented reality. So now the game, the players and the field is a hologram that you can place it in your coffee table. And you and your friends, you can wear an augmented reality device and watch the game now in 3D from multiple viewpoints and so on. So here is an example of how our system makes a 3D video, and this is the video that you saw in the beginning. And we are from the University of Washington Reality Lab, and I'm Kostantinos Rematas, and my collaborators are Erik, Michael Slizerman, Brian Curls, and Steve Seitz. And this is how we do it. So our input is just a single YouTube video, so there is no need for special equipment or multi-camera setups. It's just a single video. And the problem is challenging because now you have only a single camera to reconstruct the game, and the players are small compared to the rest of the image. And additionally, for the players, we want to reconstruct fine details such as their clothes and also the hairstyle. However, we found out that by specifying our problem, meaning that we know that is a soccer game, we are able to have pretty good results. In more detail, we start with an input frame. We estimate the camera parameters. We detect the players. We find their pose, and we track them across multiple frames. We additionally perform instant segmentation to separate them from each other and from the background. And the core of our method is a deep neural network where the input is an image of a player and the output is a depth map. And depth map is a representation of the 3D shape of the player, where, for example, here darker means that it's further away and more orange is closer to the camera. One problem is that there is not data for training such a system. However, we found out that by playing video games, you are able to generate a lot of synthetic data. And I carried out the difficult task of playing games for a couple of days to generate all the data that we needed for our network. We compared also with different approaches to see how we perform, and we found out that we perform better both numerically, but also in terms of shape completion and estimating the correct pose, and also capturing details such as clothes. Now, this is an actual prototype of our system, as it can be seen from the HoloLens. So it looks very promising, and but we want to currently we're working on making it more realistic. And in particular, what we want to do is that we want to scale the whole experience. So now that we are in a room scale, and so what it means that we want the players to be larger. We need to have higher resolution and better tracking of the ball and the camera, and overall to have a more immersive experience. Yeah, we believe that sports is a very powerful form of entertainment, and we also believe that augmented reality will change the way that we watch sports. And we are very excited to follow this direction. And thank you very much. And if you want more details, visit our website.
All right, thank you. Well done. Judges, who wants to go first? Mickey.
Hey, so that's great. I've seen the demo in your lab, and it's really cool. Do you have any sense of like how much time would it take to actually commercialize it? You know, get rid of all the artifacts that might bother some people, especially soccer fans.
Yeah, I would say for at least 6 months of working on. There are some things that we were thinking that there are low-hanging fruits. For example, have better tracking or better segmentation, which they were proven not to be so low-hanging. So I would say that something between 6 months and 1 year will be prime time. It could be like.
Viorica.
I was wondering in what other applications could you use this? Because, for example, I don't know how many women are interested in watching football or soccer, or maybe.
It is. In fact, it has to do with how you can find data. You can extend it to any type of sport that you can find either the same or similar data. For example, tennis or basketball is the easy next steps because there are video games where we can get data from. But there is also the possibility of reusing some of them, of the models that you have, or some of the data that you reconstructed for other sports.
Okay, Raghu. Matt, go ahead.
Have you done any user studies of this? Not having tried it myself, I'm curious if do people want, or do groups of people want to experience soccer this way?
We have saw it in several cases in demos in different companies also that they were visiting our lab at Seattle. And in general, we have positive feedback. One thing that you have to take into account is that we tried it in Microsoft HoloLens, so it's a wearable device that sometimes people don't know how to use it, so they might find discomfort over that. But I think that for highlights, for like sports highlights, it is a good case, a good scenario to be applied.
And Erik.
What about resolution for this? Like, what level do you need for it to be pleasant to watch like this?
So our videos, and we had a bias towards Barcelona because you can find more 4K videos of Barcelona than any other team. We were working in 4K. The YouTube videos are 4K videos. We tried also with 1080p. Then the resolution is smaller, and you can see some artifacts. For example, the segmentation is not so well anymore, but is also you can still watch it.
Yeah, but is it a good experience at 4K?
In 4K, it's pretty good.
Okay.
Jason.
So we just sat through a whole morning where we talked about how cheap and inexpensive cameras are, and now you're trying to use one camera to go do this. What if you had an install base around a stadium, whether it's a baseball stadium or basketball or soccer, and actually had some cameras optimized for this application? Then what could you do?
Then it won't be cheap. It will be extremely expensive because you need to have, for having multi-camera setups, you need to have hardware synced high-resolution cameras. And now there is only one company that is doing this. And I mean, if it was cheap, it would be possible to do. But in many of these sports, even if we say the scenario that you take a video with your mobile camera, and it is like 4K, the problem is that you are far away, so the players and the resolution, and then you have additional effects such as motion blur and etc. So it is up to now we found that YouTube it was the most easy data that you can access and have the necessary resolution to have a pleasant reconstruction.
One last question, Raghu, you want?
So I assume that you want this to be reasonably real time, right? Because it's a sports game. So what's the latency of this?
So now it is it takes some time. So it's about 10 seconds per frame. The visualization to do it is like a real time. It's like 25 frames per second. But now we're working on a version of it that it can scale because many of these parts are easily parallelizable. So we're working on a version of it that we think that we will be able to have it in real time processing.
Fantastic. Round of applause. Thank you very much, Konstantinos.